Physicists widely agree that the universe began approximately 13.7 billion years ago, sparked by a monumental event known as the Big Bang. But the deeper mystery remains. What triggered this explosion, and why did it happen at all? Over the decades, scientists have explored the origins and history of the cosmos. The Big Bang theory has long stood as the dominant model explaining the universe's birth and expansion. Thousands of researchers have contributed to countless studies, and the data has consistently reinforced the Big Bang as the most reliable explanation. According to this model, a mysterious force called dark energy, far more abundant than the energy found within galaxies, is responsible for the universe's continuous expansion, acting as an anti-gravitational push that has been in motion since the beginning. As science and technology have progressed, new theories and perspectives have surfaced, sometimes overturning ideas once considered absolute truths. Notably, physicist Miyoko has publicly questioned the Big Bang theory, a move that's gaining traction due to recent findings from the James Webb Space Telescope. This groundbreaking telescope has identified 750 newly observed galaxies that differ drastically from what scientists had expected. These revelations are prompting a major shift in our understanding of the universe. Join us as we venture into the farthest reaches of space, guided by these astonishing discoveries. If you're passionate about space exploration and cosmic mysteries, subscribe to our channel, give this video a like, share it with fellow stargazers, and turn on the notification bell. The images captured by the James Webb Telescope are visually stunning, each frame revealing hundreds of galaxies, each more beautiful than the last. Yet what's most surprising is not their beauty, but how these galaxies contradict long-held theories. Scientists were left in awe, not because the results confirmed predictions, but because they defied them. More galaxies than expected have been found, and they're quite unlike the ones anticipated by Big Bang models. These galaxies appear much smaller, remarkably older, and drastically more numerous. In fact, some reports describe the scientific community's reaction with words like panic, underscoring the magnitude of this paradigm shift. For decades, the Big Bang has served as a cornerstone of cosmology. It proposes that all matter, energy, and the fundamental forces of nature originated from a single, incredibly dense point. However, the newly uncovered galaxies are calling that narrative into question. The Webb images reveal galaxies that are 2 to 3 times smaller than those previously observed by the Hubble telescope. This is unexpected, especially in an expanding universe, where distant galaxies should appear larger over time. Even more puzzling is the smooth appearance of these galaxies. The Big Bang theory predicts early galaxies should show signs of chaotic formation, irregular shapes, and complex structures, but the Webb images reveal surprisingly uniform and mature galaxies. These findings challenge the predicted timeline of galaxy formation and evolution. The smoothness, size, and age of these galaxies suggest that our current understanding of how the universe began and evolved may need a dramatic revision. At the heart of our universe's origin lies an incredibly dense point known as a singularity. Within this singularity, matter and energy were compressed into a state of infinite density, far beyond anything we can observe today. This idea is rooted in modern physics, particularly Einstein's general theory of relativity, which predicts such extreme conditions. In this singular point, all the mass and energy of the universe were packed into an unimaginably tiny space under immense pressure and heat, temperatures far exceeding anything currently measurable. This intense, hot, and compact state is believed to have sparked the very beginning of our universe. Following this event, the universe began to expand, a process known as cosmic inflation, which started roughly 13.7 billion years ago. During the earliest moments, this expansion occurred faster than the speed of light, as the very fabric of space stretched outward. This inflation phase was crucial. It smoothed out irregularities, spread matter and energy evenly, and laid the groundwork for galaxies, stars, and other cosmic structures. As time progressed, the expansion slowed down but never stopped. This ongoing growth, known as cosmic expansion, is something scientists can still observe today through phenomena like the redshift of light, where light from distant galaxies stretches and shifts toward the red end of the spectrum due to the universe's expansion. In the earliest stages, all the matter in the universe was confined to a minuscule space. But as the universe expanded and cooled, particles such as protons, neutrons, and electrons began to form and interact with radiation. These interactions were vital to the creation of matter during the first few minutes after the Big Bang, in a process called nucleosynthesis. Initially, scientists expected early galaxies to be chaotic, formed through frequent collisions and mergers. However, images from the James Webb Space Telescope JWST tell a different story. Instead of disordered, turbulent galaxies, JWST revealed well-formed spiral and disc-shaped galaxies, structures similar to those we observe in the modern universe. This discovery challenges the long-standing theory that galaxies evolve primarily through mergers. If early galaxies appear this smooth and organized and haven't undergone significant collisions, it raises serious doubts about the assumption that small galaxies gradually grow into larger ones through merging. Furthermore, the idea that objects appear smaller due to the universe's expansion, a kind of optical illusion, doesn't seem to explain what JWST is capturing. This leads scientists to reconsider core assumptions about cosmic scale and development. Adding to the mystery, the number and age of galaxies observed by JWST appear to contradict key predictions of the Big Bang model. Using advanced infrared filters, JWST analyzes the color of these galaxies to estimate their age. Surprisingly, many of them appear older than expected, formed far earlier than current theories would suggest. These revelations have ignited intense debate within the scientific community. The unexpected discovery of ancient, compact, and orderly galaxies is forcing researchers to rethink foundational ideas about how the universe began and evolved. As JWST continues to collect more data, it's becoming clear that we may be on the brink of a major shift in cosmology, a new chapter in our quest to understand the universe. Reevaluating galaxy formation and the Big Bang theory. Insights from James Webb. Recent discoveries from the James Webb Space Telescope JWST are prompting a major reassessment of how galaxies formed and evolved in the early universe. Traditionally, the Big Bang theory has suggested that galaxies emerged over billions of years through a series of mergers, small galaxies colliding and combining to create larger structures. However, the latest images from JWST challenge this long-held view. The telescope has captured galaxies that appear unusually smooth, large, and mature, far too orderly to have undergone the frequent and chaotic mergers predicted by standard models. Even more surprising is their apparent age. These galaxies seem to have formed much earlier than the Big Bang timeline allows, raising serious questions about the accuracy of our current understanding. Another factor reshaping the discussion is the distribution of galaxies revealed by JWST. According to conventional models of an expanding universe, galaxies should become more spread out over time. Yet, Webb has shown regions where galaxies are densely clustered, defying expectations. This anomaly suggests that our models of cosmic expansion may be incomplete or in need of serious revision. These findings could mark a turning point in cosmology. They suggest we may be entering a new era of scientific exploration, one where foundational theories like the Big Bang face intense scrutiny and possible transformation. Such is the nature of science. New evidence can challenge the status quo and lead to paradigm shifts in our understanding of reality. As more data pours in from JWST and other advanced instruments, our picture of the universe's birth and evolution will continue to evolve. It's entirely possible that future discoveries may upend the Big Bang framework and force a complete rethinking of cosmic origins. While these revelations raise more questions than they answer, they also offer a thrilling glimpse into the universe's complexity and mystery. Currently, the scientific community is divided. Some researchers remain committed to the Big Bang theory, while others are beginning to explore alternative models of cosmic formation. What's clear is that the James Webb Space Telescope has opened new frontiers in our quest to understand the universe. Its discoveries are sparking critical conversations and redefining what we know or thought we knew about the cosmos. As we continue to explore the early universe, these observations may ultimately reshape our theories of existence and inspire the next generation of cosmic inquiry.